Okay, the conditional probability lecture number 2. If you just recall what we did in the last class was conditional probability lecture 1. We worked upon the condition when we said that there are two distinct events whenever we talk about the conditional probability. So probability is probability of an event under given condition upon probability of the given condition. Now, given condition were the mode of the transport and the feeling during the transport. The mode of the transport were horse, elephant, and camel. The probability was 0.6, 0.3, 0.1. If traveling by horse, then the feelings were afraid and not afraid. Being afraid was 0.85, being not afraid is 0.15. If traveling by horse, if traveling by elephant, the probability of being afraid was 0.45, probability of not afraid was 0.55. If traveling by camel, then the probability of afraid was 0.35 and probability of not afraid was 0.65. Considering that we made sure that we calculate the total probability of afraid, which we ended up finding 0.68, and we found out the total probability of being not afraid, which was 0.32. Now, when we talk about conditional probability, we talk about probability of an event under given condition. So that means, let's say that given that Ayan is afraid. Now, it is already, we already know that Ayan is afraid and it is the condition that is applied. Find the probability that he was traveling by horse. So now, considering what? Considering that he was traveling by horse, right? Find the probability that he was traveling by horse, but given condition was afraid. So we will always say that horse, he was traveling by horse and he was afraid. So horse afraid probability would be divided by the total afraid probability, because the formula of the probability condition probability is probability of the given of the event under given condition. So the event is traveling by horse, and the condition is afraid, and the given condition is afraid. So that means here particularly that we'll be working about the event, which is horse, condition that is the afraid. So horse afraid upon probability of given condition that is afraid. So noting that the condition is there, so what we're going to do is probability of horse and afraid upon the probability of afraid. Now, the probability of horse afraid under the given condition. Now, we already knew that horse afraid is this. If this was horse, 0.6, and afraid was 0.85. The answer of horse afraid was 0.51. And total probability of afraid was 0.68. So if we just divide by 0.6 into 0.8, 0.6 into 0.8, this will be 0.6 into 0.85 divided by 0.68. So the answer would be 0.52 divided by 0.68. So probability of traveling by horse and is afraid upon the total afraid is 0.750. Now, what does this mean? This means that we are finding out the horse afraid probability from the afraid probability. That means now the probability was what? Afraid, but So finding out the probability of traveling by horse. Traveling by horse. So that means we are finding probability within the probability. So the probability within, that means 0.750 of 0.68 will be the probability of horse afraid. Now we can also work out with another given example. Let's say find the probability, find the probability that ion traveled on an elephant. Now we know that ion traveled on elephant. Now, if he is traveling by elephant, given that he was afraid. Now, the condition is afraid, but now we know that he's traveling on elephant, so he should be afraid. So elephant afraid upon, given the condition was afraid, so elephant afraid upon afraid. So the probability for this will be, the formula which we'll be having is elephant afraid upon probability of afraid. The elephant afraid probability comes through the tree diagram again. So this is your elephant afraid. If you just see elephant and afraid. So 0.3 into 0.45, we end up having 0.135. So this is probability of elephant afraid upon the total afraid was 0.68. So again, back towards the normal working, this should be 0.3 into 0.45 upon 0.68, which will be 0.135 upon 0.68. So the probability will be 0.1985. Now, this means that the total probability was 0.68. So out of 0.68, the probability of the afraid being elephant is, that is 0.985. That means probability within the probability. Probability of the 0.68 of elephant being afraid is 0.185. That means if we add up all the probability of horse afraid, elephant afraid, and camel afraid, we should end up getting 1. So let's just prove this. Let's say ion was afraid. What was ion? Ion was afraid during the journey, right? Given that ion was afraid, find the probability that he was on camel. Now we already know what? We know that he is on camel and afraid upon afraid. So camel afraid was 0.1 into 0.35 upon 0.68. So what we have here is 0.198. No, correction. The answer for this will be 0.1 into 0.35 divided by 0.68 is 0.0514. So if we just add all the values, that is 0.750 plus 0.1985 plus 0.0514. The sum of this will be equal to 1. The sum of this will be equal to 1 because these all probability reflect that this is the ratio of the probability of 0.68. That means of 0.68, basically you are taking out different probability, which is 0.750 for horse afraid. This is 0.98 for elephant afraid. And this is for camel and afraid. So this was probability within the probability. Probability within the probability. Let's just now change the type of the question. If the question would have been given that Ayan is not afraid, find the probability that he was not on a horse. He was not on a horse. So what does this mean? This means that the condition that is being applied is of not afraid, but he was on a horse. So horse not afraid upon the total not afraid. Upon the total not afraid. So if we just write this thing down, we know horse not afraid upon probability of total not afraid. So horse not afraid, we ended up having what? Horse not afraid, we end up having what? That means not afraid is 0.32. Given that Ayan is not afraid, find the probability that he was not on horse. So not on horse means horse and the not afraid probability. We can always also find out. Let me just correct this. This means that what we end up having is two things. That means we can end up having elephant and not afraid, or camel not afraid, and or we can also have that probability of horse not afraid upon probability of afraid plus probability of elephant not afraid plus probability of camel not afraid upon not afraid should be equal to 1. So what we can have here is 0.3 into 0.55 plus 0.1 into 0.65. So the answer for this would be 0.72. The answer for this will be 0.72, or probability that we need to find out elephant not afraid plus camel not afraid upon probability of not afraid will be 1 minus probability of horse not afraid. So in this category, what we can have is 1 minus 0.28 will also become what? 0.72. So that, what does this mean? This means that the question was very clear that given that Ayan is not afraid, find the probability that he was not on horse. So if he was not on horse, he would be on camel or he will be on elephant. So if he is not on horse, so that means your elephant and your camel probability will be taken into consideration for not being afraid. But if he was on horse, then the probability for this would have been changed. The probability for this would have been simple. Same question, given that Ayan is not afraid, find the probability that he was on horse. Now, in this statement and the statement here are two different statements. This means he was on the horse. So we need the property of horse, not afraid. Here it says he was not on horse. So if he was not on horse, automatically he will be on elephant, not afraid, and he would be in camel, not afraid. So there would be two things that will be required. Here it is only the horse that is required. So the probability that we will be working upon will be horse, not afraid, upon probability of not afraid. So horse, not afraid, probability will be taken into consideration. Knowing the tree diagram that horse, not afraid was 0.6 into 0.15 upon not afraid was 0.32. Not afraid was 0.32. So this is 0.09 divided by 0.32. So we will end up getting the answer for this. The answer for this will be 0.28. So noting that the significant change in the answer of any question will be upon the statement of the question. If the statement of the question change, then automatically the probability will also change. Okay, let's just continue with the question. The question is quite clear. It says that this is from June 2008. From the book, it is question number 4. A country A has 30% of the people who drink tea have sugar in it. Country B has 65% of people who drink tea have sugar in it. There are 3 million of people in country A who drink tea and 12 million people in country B who drink tea. A person is chosen at random from these 15 million people. Find the probability that person chosen from country A. So if I want to have from country A, probability of country A should be 3 upon 15 million. So the probability will be 0.2. The probability will be 0.2 because obviously if you want to choose a person from country A, it should be 3 upon the total person, that is the 15 million. So if even from country B was asked, the probability would have been 12 upon 15. So the answer for this is 0.8 if it was asked. Now, find the probability that the person chosen does not have sugar in their tree. Now, if you just look at the question is very unclear. It says does not have sugar in the tree, but the question does not say anything that is it from country A or it is from country B. So that means it's an open-ended question. We need to have from country A does not have sugar. We need to have from country B does not have sugar. That means we need to have the total of people who does not have the sugar in their tea. We need to find the total. So let's just, for the sake of the working, let's just draw the tree diagram. We knew that there were two countries. One was country A and country A, country B. The population of country A was 0.2 and the population of country B was 0.8. Because we'll be working on the probabilities now, right? So the probability of country A population is 0.2, the probability of country B population is 0.8. So if we say sugar in it and sugar not in it, sugar in it and sugar not in it. If we knew that 30% of people who drink tea have sugar in it in country A. So if it is 30%, that means 0.3. So if 0.3 people have sugar in it, then 0.7 people will have no sugar. Similarly, 0.65 people have sugar in it in country B. So 0.65, whereas 0.35 will be taken into consideration here. So this means this will give me probability of country A, which is with the sugar. And this is country A with no sugar, country B with sugar, and country B with not sugar. So if we just find out the probability, the question says find the probability that the person chosen does not have sugar in it. So the person chosen does not have a sugar in it can be from country A as well as from country B. So if it says probability of no sugar, obviously country A no sugar plus country B no sugar will be taken into consideration. So country A is 0.2 and no sugar was 0.7 plus country B was 0.8 and no sugar is 0.35. So 0.14 plus 0.28. This will have the total probability of 0.42 of people having no sugar overall. Either it is from country A or country B, both have no sugar. Now, in part C, 3, if you see, the question is very clear. The question says, given that the person chosen does not have sugar in their tea, the person chosen does not have sugar in their tea. Now we know that condition is applied, does not have sugar in the tea. And the total probability of this was 0.42, we just calculated in part 2. Now, what else we need? Find the probability that the person is from country B. We need to have from person from country B. So country B does not have sugar upon does not have sugar total. Country B does not have sugar upon does not have sugar total. So if we just want to find out part answer for part 3, so what are we going to do is we're going to work out the solution for part 3, that probability of country B no sugar upon total of no sugar. Now country B total of no sugar, because the question says does not have the sugar in their tea. So the total of no sugar is 0.42. Total of no sugar was 0.42 and country B no sugar was 0.8 into 0.35. So this is 0.8 into 0.35, which is equal to 0.28. That means 0.28 of 0.42 will be the probability of country B no sugar upon no sugar. That will be the total.